Google Brain seem to care about in their patents are distillation and distributed training. But yeah, there's not a lot of literature.
Isn't there something, I think some Russians did it, relevancy detection on the weights of a network, which then, upon repeatedly doing that, essentially drops connections because they are not that useful in transmitting information to the network. And then
Yeah. So
I think that's a very similar thing, but it's slightly different.
It's a similar principle because it's, I can't remember what it's called, when you kill connections.
Sparsity enforcement or something.
Yeah, something like that, right?
If you know the paper, that would be actually something good to talk on, I think.
Yeah.
I don't know the paper anymore. So.
I think they're called sparse networks, but I'm not sure.
I mean, would it be very difficult to L1 regularization?
I think that's interesting.
It's
It's basically, it's not distillation anymore, but it's one form of model compression, right?
Yeah.
If you create a sparse model, it's going to take less weights.
Oh, yeah. And remember that I could get rid of almost 100% of all the links and still worked with super high accuracy. It's crazy.
In fact, we were at a talk at IBM that was talking about different policies and strategies for creating sparse networks. To be honest, I wasn't paying that much attention. Because it was
broken
yeah, it was the guy at ICML with the broken microphone, correct? So we didn't hear a lot. It was also at lunch. So, but yeah, sparse networks is another form of model compression. There's binarization. So there's actually another EF company called Pluralsight who are working on binarization of networks to be loaded into hardware. And of course, like, binary is small and probably faster to capture. Can't think of any other effective way of model compression. Like, distillation is interesting because you can change the type of model, right? Sparse networks you can't. Binarized networks you can't. Like, you're just making it less granular, I suppose, in ways. But this is interesting. Like, so when we'll look at the paper where they distill a network into a tree, that helps for different reasons, which is a tree is explainable, right? Ish. At least you can know what it's doing it and how it came to a conclusion. And so there's talk about like having a companion tree to a network to try and help describe what the network is doing, even if the companion tree has lower accuracy. It becomes sort of a way of explaining by proxy, and that's done with distillation. Cool. So, hands up if you're here for the first time. Alright, everybody else has heard this before.